Okay, so hello everyone, I'm Karina. My presentation today is about big data analytics with Sparks. So what I can say about Spark, this is the structure of my presentation. I will first introduce Spark and position it with respect to Hadoop. Then I will cover Spark applications, the resilient distributed datasets, what I called RDD. After architecture and its main operation, I will briefly present the main modules of Spark, but only give some detail about SQL and some of them about machine learning libraries. Finally, I will conclude. So let me start. What is Spark? Before talking about Spark, it's better to start with some overview. I don't know if you already heard about APAS software. So it's from UC Berkeley. And in this, they produced or they proposed one framework. This framework enables to process data, distributed data quickly. So it's called MapReduce. And MapReduce come first before Spark, but it doesn't enable to do some processing work with using some machine learning algorithms to process graph, to process data mining. So with MapReduce, you can't use R, Python, Excel, and whatever you want. So based on these limits, they propose to extend MapReduce for two classes of analytics application. So it's possible now with Spark to use machine learning or to process or to pre-process your data, to use some algorithms to process graph data. And based on this, they enable us to use another kind of languages, such as R. You can use Python, Excel, and now with Visual Basic Studio, so some software around it. Another part is about performance, because when you want to process distributed data, you need to take into account performance. So they improve it by using in-memory processing, try to optimize, or they optimize the task of the graph. And now many industries can use Spark. So what is Spark? Spark is just a real-time data processing or batch processing. It's enabled to process your data by using some libraries for parallel data processing on computer cluster. And why it's a computing engine? Because with Spark, you can focus on computation. You can load data from storage systems. You can perform it. You can use Spark with a wide variety of persistent storage systems. So it enables to compute or to parallelize or to process your data on computer cluster, but they add some libraries. For example, if you want to analyze your SQL data or structured data, you can use SparkSQL. If you want to use some machine learning algorithms, it's possible with MLlib library. You can process your stream data by using some batch processing treatment. You can process your graph or to do graph analytics with graphics. So when we talk about Spark, it's important or mandatory to know something about Spark model. Spark is based on RDD. What is RDD? RDD is just a collection of objects. We'll talk about it into the detail very quickly in the next slide. So this RDD is built from parallel transformation. For example, you can use some operation like map, filter, reduce. You can join your data. You can reduce your data. So what is important to know about it is that it's maintained in memory, because if we want to process our data efficiently, it's Spark gives these opportunities to use data, to use RDD in memory for efficient processing. So RDD use some operators like transformation and actions. About Spark, we talk about is data model. So the main concept is RDD, but is useful to know something about the Spark tool. So about Spark, what I can say is Spark consists of 6 parts. First part is about programming languages. The second part, if you want to process your stream data, structured streaming data, it's about this high level. So here we can process everything about streaming data, whatever you want. Here it's the part of, it's about advanced analytics. So if you want to use or anything about big data processing and data science part, it's here. So we have in Spark some libraries and ecosystems. We can use to process all of this by using 2 kinds of APIs. First one is a low-level API. So we talk right now about RDD. We can broadcast our data by using distributed variables. We can process structured or unstructured data or semi-structured data by using structured API. So it's called, it consists of datasets, Dataframes, and SQL. So now I will go into the detail about each part. First, I will talk about this part, programming languages. So about languages, Spark enables to use Python, Java, Scala, and R. Now, since last month, I saw that now it's possible to use Visual Basic. So the Microsoft software, programming languages, sorry. And after that, we talked about high-level API. Now, what I can say, this one allows to rapidly and quickly extract value or out of streaming system with virtually, so no code change. It's easy to conceptualize this. About advanced analytics, if you want to use some techniques, for example, to make prediction, recommendation based on data, you can use advanced analytics. So in Spark, you have some ecosystem. So it consists of packages and tools created by the community, so Spark community. About libraries, we have a unified API for data analysis. Spark provides more and more types of functionality. So we have hundreds of open source external libraries. With Spark tools, you can process your structured, manipulate your structured data or unstructured data. So if you have CSV, the Parquet, you have XML data, whatever you want, you can process with Spark. So you can use manipulate distributed data by using RDD. You can use broadcast variable accumulators in order to distribute and manipulate your distributed shared variables. So now we talk about Spark application. When you use Spark, you know about Toolset, about the main concepts called RDD, but it's important to know about Spark application. What is it? How many components you have in this Spark application. So about Spark application, what is it? It's just a set of Spark jobs. When you have Spark, you need to run your jobs. So you come to run your jobs without using Spark application. So it's just a set of Spark jobs defined by one SparkContext in the driver program. In Spark, we have two components. The first one is driver. Driver is master. It's enabled to run the main function sits on a node or cluster. So what is the purpose of this driver? It enables to maintain information about Spark application, to respond to a user's program or input, to analyze, distribute, and script their work across executors. So executor here is just a slave. It carries out the work that the driver assigned and try to execute it. So, for example, this is a SparkSession. Okay, this SparkSession is just a driver process that enables to control Spark application. We know that Spark application have two components: driver process and executor. This one is a Spark application. So here we have a driver program that communicates with the appropriate cluster manager to run this task. We have here, it's a Spark PySpark code. So we use PySpark library in order to transform or to process this data. We have some row about country and later. So now we give some input like destination of this country, origin of country, and we count how many times maybe they used this destination. So I talk about Spark applications. This one is architecture. In this figure, we can see the driver on the left and the 4 executors on the right. So it demonstrates how the cluster, so here is the driver, executor. So here it demonstrates how the cluster manager controls physical machine and allocates resources to Spark application. We have SparkSession inside of driver process and user code. And we have a cluster manager. This cluster manager enabled to manage everything about driver and executor to control what driver are doing and what executor are doing and try to maintain the system in order to execute correctly each task. So about Spark, it's important to know which language Spark can use. We already talked about it. Spark comes with a default language. It's a functional language called Scala. We can use Java, Python. They support SQL, R, and they can use some Spark Core or our community-driven package. So if you want to use other languages with Spark, it's enabled to know what is the relation between SparkSession and each Spark languages. So Each language API, for example, here in this figure, we have Python process, R process, we have JVM, inside we have SparkSession, and executors. So we already talked about executor that take just each task comes from driver and try to execute it. So now it's about how to translate the Python or R process into SparkSession in the SparkSession in order to process or to execute it in executor. So here, SparkSession, each language API maintains the same core concept that we described earlier. There is a SparkSession, okay, SparkSession object available to the user, which is the entrance point to running Spark code. So here, when we used Python or R, you don't write explicit JVM instruction. Instead, you write just a Python R code, and Spark translates into code by using SparkSession. It then can run on the executor. So JVM take into account all of these and translate it and start by using SparkSession is part to the executor. So we have in Spark in Spark we have a distributed data set. It's mandatory to use it in order to process the data. It's just a low level API in Spark. So it's a set of objects used in memory. So it's possible to cache this data. To read only, it's just a read-only collection of objects. We can partition across machine of a cluster, and we can reboot when we have failure. For example, this one is RDD construction. So an RDD can be created by reading the information. So we have a file here, and we store this file, file system called AGFS. It's Hadoop distributed file system, sorry. Or you can say this one, this RDD, this set of information of data or data in your folder or whatever you want, wherever you want, sorry. So here we have RDD, is just a text file. We store it, we parallelize it, okay, and we try to transform this RDD by using some operation. For example, filter. What is important about this operation? This operation that we have two kinds of operation. We have transformations and actions. What about transformation? What is transformation? We have on one input is an RDD or many RDDs, and the output will be RDD. It's just a lazy applied. Okay. Action is about RDD. With this RDD input, we can produce a value as an output. For example, about transformation, we can have a filter. I will take this example. Here we have a key, okay? We have one table. It consists of key and value. We have two keys, Alden and Panda. Okay, for example, value, we have like coffee. We have here Panda likes long strings and coffee. So we apply a filter condition or operation in order to take just the valid key based on our condition. The condition here, for example, I want to take a key equal Alden. And when I take this key, it's mandatory to give me a value. Okay, so here the result, so here I have an RDD. This one. is an RDD. Okay, it's just a set of data. Inside we have information, and the output is on RDD. So maybe this one, it stores in maybe C, I don't know, Karina, Jongwei. I have one further. I don't know, I can take conference. Okay. Okay, and I started as a test dot, for example, I don't know, txt or csv, no, whatever, it's ever txt, sorry. So I have another example. Input RDD. Okay. I have here a key, a set of keys. So I have 5 keys. First one is Panda, second one is Pink, Pirate, Panda, Pink, and the value 0, 3, 3, 1, 4. I will use this operation named map values in order to collect all keys and values. So this one is a value, and I have here one pair key and value. So here is 0 value, here occurrence of each key. Panda 0. How many pandas value 0 we have? Just 1. Pink 3. It's okay. It's this one. This 3. Okay. How many pink with value 3 we have? Just 1. Correct. Same for this one. The same for this one, and for pink 4 and 1. So I will do the same thing by using reduce by key, by using reduce by key operation. So I have here key and value, same table with the same columns, but here we can see we have different rows. So instead of 1, 2, 3, 4, 5, here is just 3. If I remove key and value row, we can do this reduce by key. We see that we have Panda, okay, Pink, it's okay, and Parrot. So we have Panda 1, okay. Why it's 1? It's 0 plus this one. The sum of this is result 1. Why is it 2? Because we have Panda here and we have Panda here. Correct? 2. Pink 7 and 2. Is it okay? I don't know. I will check my result. So this one is pink. I have 3. This one pink. 4. So 3 plus 4 equal 7. So it's okay. Why is it 2? Because we do this one. 1 plus 1 equal 2. I have here Parrot. So 3. Okay. And 1. I just have 1 of this. Okay. So after using this operation, reduce by key, so this one is the first one. The second one is reduced by key, and the third one. The last one is map values. I will collect the same thing. So I have 1, 2, 7, 2, 3. Okay. So about transformation, if I summarize, transformation is this one. I have RDD as input, and I produce on RDD. Or I can have several RDDs. So set of data, and at the end I have one RDD. Okay, so we talk about transformation. Now, when we talk about operations in Spark, there are two kinds. We have transformation. We already talked about it. Now, we talk about actions. Actions, we have RDD, one or which you want, several, and we have value. Okay, for example, one of these is a reduce function. So this operation, we have 1, 2, 3, 3. This one is, we have here set of data, RDD. Okay, result here, we have value 9. Okay, so what we did, 1 plus 2 plus 3 plus 3 equal 9. So we just do this one in order to have RDD.reduce result 9. The action we can collect. There are many actions. Here we have a set of objects, 0. So each one in different partition. Partition 1, for example, 2, 3, 4. So we put all together by using collect. So they will give us this one value. Set of all of this in just one file. You can save it in one file or whatever you want. The best example, or one of the most example used in Spark, when we talk about Spark or Mark peer reviews, it's word counts. For example, we have a text file here. Okay, my text file, sorry, is for example, I can take text dot txt. Okay. So here, for example, I put hello, my name is whatever you want. You can write, and you have another hello, for example, here. Correct. We have several words here. Correct, for example. So what do we do? This one is on RDD. And I saved it in one file called text.txt. It's a text file. I use my SparkText file in order to save it, to take it, sorry. So I see that I start in file system, input path, and here there is my text file. So I have one value. Sorry. Here, what I will do in this line, I will use one operation called flat map in order to split each line of my text file. After that, I will map using this operation map in order to count each word, the word and occurrence here, and I will reduce by key in order to have, for example, here, how many times I used each word. For example, this one I can have in the file, sorry, I have one file. What file, for example, hello. Okay, hello, for example, something like that. 2, for example, 3. Correct, for example. One, 4. And so this one is this result, the result of this when I reduce by key. And this one I will use the save as file operation in order to save it on AGFS. For example, the result, it will be result dot just a text file. Okay, so this one, you see that here we have this variable, these words, and we have many variables. But by using Scala language, we optimize the code. Just have one variable counts, and inside with this we can flat map, we can use this operation and this one, and the same counts we can save as text file. So we didn't change here. For example, we have words, one counts, and whatever, and others. So this one is a kind of graph in order to summarize all operations we used. Input text file. First one, we used flat map. Second part, a map. We reduce by key, and we have a result. So we already talked about RDD. We talked about RDD. We talked about Spark application architecture about it. It's important to talk about another kind of dataset. Why? Because when we talk about a toolset, so here we already talked about RDD, distributed data variable to broadcast your data or your variable. So now we talk about this part. It's important to manipulate structured data by using this structured API, or to process or to pre-process your unstructured and semi-structured data. So if you want to manipulate it, you need to use datasets or Dataframe and to run your SQL queries. So what is a dataset? What is dataset? What is dataset? So it's just a structured API. But if you want to manipulate datasets, it's mandatory to use Java Virtual Machine Language feature that's work only with Scala and Java. You can't use R or Python. So when to use dataset? Because we know that it's possible to use RDD, but it's a low-level API. So when could I use dataset? When you have some operation you would like to perform, for example, some operation, you can perform it with a data frame. We'll talk about it next slide. And when you want to, or you need a type safety, and you need to take into account, because of performance, it's better to use a dataset. So this one is an example. If you want to create your dataset using Java, it's mandatory to use encoders. Okay, this one is using Scala. You saw that here we have how many lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But here is just, we optimize because it's simple with Scala. We have just 1, 2, 3, 4, 5, 6, 7. Okay. So to create datasets in Scala, you define a class, a case class. It's this one. And is a regular class that has the following characteristics. It's immutable, decomposable for pattern matching. It allows for comparison based on structure instead of reference, and it enables to use and manipulate. It facilitates some processing parts I can use. So about datasets, there are some operations too. We can use actions or transformations. So we can join, grouping, using aggregation, whatever you want. So about, we already talked about Spark applications, SparkSessions, and we say that we have two components, driver, we have executors. So now when we talk about executors. Okay. So about executor, what is important to know is that it consists of 4 parts, if I can say it. We have here the tasks. We have here the cache. What is the purpose of this cache? The cache, for example, it's enabled if you have your data. So you use a cache in order to operate your data. So it's here if you want to operate the data. So if you want to use, for example, some reduce by key parts, everything about joins over parts, it's here in the shuffle parts. So about partition of the data, for example, if you have your data and you want to partition the data, is here in this part of data, and the number of tasks to execute some tasks is here, and for each task we have different curves. So, and threads, internal thread here. So all of these, we saw we have JVM, and in this JVM part we have a SparkSession. So this here, what I can say, for example, we have different job and we run it. We can executor enables to use a cache, for example, to process to take each RDD. You can partition the RDD, or if you have some joining operation, like joining or reduce by key operation or whatever, everything will execute, Spark will execute it here, shuffle out. So when executing Spark in a local machine, we used two kinds of deployment. It can be local. Why? Because we use just one executor driver inside. We can distribute our data by using one driver and several executors. However, Spark is normally executed in a distributed cluster, and about it, there are three ways if you want to deploy your cluster in Spark. So it can be a standalone part, a yarn part, or Mesos part. So about Mesos, Spark Standalone. In Spark Standalone, there is a master, this one, and a set of workers, normally one per machine. So first one, a master is a running Spark instance that connects to cluster manager for resources. So the master acquires cluster nodes to run executors. There we call a driver. We saw that a driver is there in order to give some tags to each executor. So here we have a workers. So a worker is slaves here are running Spark instance where executor like to execute tags. So when executor master call the driver in order to say that I have a task and you need to compute it, to give me how to compute it. When the client, for example, we have a client here, one client here, okay. One client submit a job here. A driver program is created like that, and after that, the driver program then communicates with the master to start the executors. So we see this connection here, this one. And after that, a master is running Spark instance, this one. This one is a kind of, and that connects to a cluster manager for resources. And the master acquires cluster nodes to run executors. And after that, after running Spark instance where executor like to execute task, there are the compute nodes in Spark. So now the master can have some result and give it back to the driver, and the driver can communicate with the client, and the client will take this result. So directly, so we have different information. We come back to the driver, and the driver, we give it to the client or clients. We have another part if you want to run your cluster using Spark. We have a yarn. So when used in yarn mode, the behavior is similar to the Spark Standalone, but the difference here, we have name node, and M for name node. Here, we have a resource manager. Okay, so yarn is the resource manager included in the version 2 of MapReduce. In a yarn cluster, there is a resource manager which is enabled to assign resources to applications. Okay, and a node manager can it's a kind of slave can call it slave, it's better. Sorry. Okay. Slave. It enables to launch and control local containers. So here, as before, we have our driver, we have driver resource manager, we call driver. As before, the client starts a driver which contacts the, so we have here the client, for example. The client starts a driver which contacts the resource manager, and the resource manager will create a container. So this one is a container for the application manager in the client mode. The application manager is just in charge of demanding resources to the resource manager, and after that, the driver will start each process and use or call the app manager, and this app manager, after that, can have a container. It will ask for the container needed to launch the Spark executors. So on each of these containers, an executor is initiated, and from this point, the driver will communicate directly with the executor. So about yarn part, we have two deployment modes in yarn. The yarn client, which behave are presented before, and the yarn cluster. So the only difference between yarn cluster and yarn client is that in yarn cluster mode, the driver is executed inside the app manager. For example, here we see the yarn client, we have the driver outside of app manager, but in the yarn cluster, we have the driver inside of app manager. So this lets the user stop the connection while the job will continue to execute. So now let's talk about operation. We already talked about operation. Operation, we say that we have two kinds of operations. We can use transformation or action or both together. So when you have it, it's important to schedule. It's important to schedule our operation, even if it's transformation or action. So we already know what is RDD. So for example, we have this output, a kind of graph, direct acyclic graph. So we build operator DAG. We have RDD and different operations. For example, first part is join, map, growth path. So the task here is to know where could I start and when could I start or stop everything. And if I use, for example, join, what is the cost of each operation? So we built our operator, build operator direct acyclic graph. So now we can split it into stage and submit each stage when ready. So we can see here we have a stage, a partition, and a task. And a task scheduler before launching individual tags. We try to see which task or which partition or task it's important. If I need to start by this one, and this one, and executor after that can start to execute. So for example, here about scheduling, I have here my text file, so an RDD text file. I will flat map in order to parse each line. And after that, I can use some operation, for example, like map reduced by key map in order to process this text file. So this one is a tag simple with my text, flat map, first stage. So this one is stage 0. Okay, and there is connection. After this map, directly I will start reduce by key stage 1. Okay, map. And after that, we talk about how to split each part. We already split it now. So split tag in this. So now the task dollar will launch my part. So I split. Here I have, for this stage, I have, for example, syslog tag macro, map partition RDD. So is this one. They try to map partition my RDD. After that, I partition my RDD by using, so in this flat map. So flat map. After that, so first one, sorry, I have this one, this log, map partition RDD. After, I have my flat map, so it's this one. After that, I have this one, I can map now. I split it into some stages and whatever. Now reduce by key parts, and the last one, another map. So about the shuffle, it's just a repetition of the data. For instance, we can searching, data frame, joins, aggregation, grouping. So for all of this, it's important to separate stages in the DAG. So what I can say, we already talked about datasets, RDD, a toolset. So now I will go into the detail about SparkSQL. So how could I process my structured and unstructured data, and quickly about Spark streaming, Spark MLA. So for those who want some books about machine learning with Spark, it's very easy and simple. I have many books about it. I can share with you. And for the same thing for processing graph data with Spark graph FX. So here I have what I can say. So there is one part about languages. This part we can see if I want to use SparkSQL, which how many languages I can use. For example, here Scala, Java, Python, and R. For SparkSQL, I can't choose for Spark. If I want to process stream data, I can use Scala, Java, and Python languages. If I want to process to use some packages with machine learning, it's possible with Scala, Java, Python, and R. But about graph, it's only use Scala. So for each of these, we have a specific library. We have Apache Score, Spark, and eScore in order to process all of this. So quickly, I will talk about SparkSQL. So what is it? SparkSQL provides the ability to run SQL on top of Spark. And Apache Spark module for structured data processing. It defines an interface for a semi-structured data type. Okay. For semi-structured data type, for example, and the SparkSQL library enables relation processing, high performance, support of new data sources, enable extension. For example, if you want to use advanced analytic algorithms such as graph processing, machine learning, and whatever you want. And about SparkSQL, for example, here I want to create a data frame in order to manipulate my SQL query. And I manipulate it again as data frame. So, for example, here I if my Spark is an existing session, I use SQL method in order to create this table and check if it exists, for example. And by using if, now I will load my data in a local path. And I can query by using expressing some, for example, I want to select all data from source and to show this result. So when I did it, I can see I have a set of keys. So I have here key value set per. So here I have keys and different values. So when you want to use SparkSQL, it's important to use Dataframe. Dataframes are a table, represents a table of data with rows and columns. So this one here, we have 2 rows, for example, and we have several. We have 2 columns. 2 columns, and 3 rows. So it's just a distributed collection of data organized into named columns. We can create it from existing RDD, okay, by using schema inference or schema specification. We can create it by using data sources, for example, over data sources, CSV, Parker, JSON, Hive, and over. And we can manipulate it using some operation as like transformation or actions, and we can use some SQL queries programmatically. So data frames are immutable, lazy valued, planes. And about transformation, it's the same one. We can build logic transformation, use narrow dependencies, and write. For narrow dependencies, each input partition, we contribute to only one output partition. We have here wide dependencies. We have input partition. It will contribute. They contribute to many output partition. So we have some action. So, for example, I say that here we have narrow dependencies. So each input partition we contribute to only one part. So we have here each one, and here we have one partition. For the wide, we have one partition. With this one, they contribute to have several partitions. So this one is an example of data frame. Okay, created using Scala. We have here from some data variables, and from each variable we have here the type. So same thing. I have a log file. I use flag map operation, and so I produce my data frame. So this one is a schema inference route. We have here different all variables and different types. Same thing here. I try to query with Dataframe API by using some operation as filter, group by, count, filter, and I sort it ascending and descending. And I try to limit it by saying I just want to show 5 rows. So here we have 2 columns about application and count. For each application, we have a value. So for number of time Okay, so now it's the same thing by using directly SQL. Here is with ordinary operation. This one is we used SQL, so we can see select application. We say that I have application. I need to count as the name of this column. We call it count, and I applied some group by or other by function. So something here, I have I specify schema, and I have my schema here. So when you used SQL, it's important to talk about optimization. Why? Because we have several operation or function and operators, sorry, and we need to process each one. But when you want to process, you need to take into account some cost of optimization, the cost of processing. So here, in order to do optimization, we used Catalyst Optimizer. It's inside of Spark. So we have here, this will help you to understand how to process data with Catalyst Optimizer. So we have here entrance, SQL, or Dataframe or Datasets. It's what we said. If you want to manipulate structured data, it's compulsory to use 3 of them, or 1 of them. You can't use RDD. So inside, we put each of these in a Catalyst Optimizer, and we have here Catalyst Optimizer will produce a kind of query plane in order to execute each operator. For example, here, so P is just an alias from people. This P is just alias from people. So people.id. I have my table. My table can be like that. About people. Okay. So here I have 2 columns. ID. And I have a name. Okay, for example, ID1, ID2, ID, okay. For example, 1, Elohim or Musa, the name Musa, and whatever you want. So I want here to select the name, okay, the name. So this column from, I have a sub query. Inside, I select a name and ID, okay, from people, where PID equal 1. So I will have this one. So here, this is a usual logical plane. First operator is projection. So with this project, so I have first table, my table people. I project in order to have ID and name, these 2 columns. And in these columns, I need to filter. So this one is the condition. I just want to have ID to take all information about ID equal 1. And after that, I will project in order to have the name. For this logical plane, this one is the corresponding physical plane. Okay, and first I will find filters on the top projection. After that, we will check that the filter can be evaluated without result of the project. If so, we will switch for operators. Why? We will switch the filter push before, because, for example, if we have 1 terabyte inside our table, if we didn't push this condition, we must try to analyze each row. So it will take time. So what we did is to push first to filter push down, okay, this condition, and like that we can remove and to prune what is not important for us. For example, we have just this information about ID 1 and the name, corresponding name. So we can project directly to have ID and name. After that, we can project in order to have just a name, for example. So about data frame optimization, it's one part of the work published on Sigmod. And there's support rule-based and cost-based optimization. For example, about the cost-based optimization, we have some statistics here, cardinalities, and whatever. So about rule-based is, for example, to know, it's important to know what is the cost of pushing first projection before filter. For each operation, we have one cost. So in order to choose the right or the correct, the first operator, we need to take into account of rule-based optimization. So Spark performs standard optimization, for example, predicates push down, projection, propagation, Boolean expressions, for example. So first, we have a user code. It can be a SQL, Dataframe, or a dataset. Here, okay, we have a user code. Directly, we have on result logical plane, and the catalog. Here we have some cardinalities. We have some statistics. And we can check about this plane. For example, first one, we have a table people. First one, for example, projection, project. After that, we have a filter condition. For example, we have another table about professor, for example, and we can join, do something. We can join in order to have, for example, ID of people or whatever. So based on this, we have this unresolved logical plane. Catalyst will analyze and check if it's correct to start with project after filter. The last one will be join. It's not correct because the join, it's too difficult to use joins because you have many input and output every time, and there are many costs. So we try to resolve it by saying first, for example, I will filter. Maybe it's not mandatory to use to join the table by using this in people, it's better maybe to perform join operator in professor table. I don't know, something like that. But all of this is based on catalog. After that, we have a logical plane. It's already optimized, and it will give us an optimized logical plane. So this one is a process. I have my optimized logical plane. The same plane, Catalyst will transform it in physical plane. Okay. And after that, based on the cost model, we have an optimized based physical plane, and we will Spark will execute each part, each jobs, or each operator on the cluster using Executor. So about Spark streaming, it's just a library that is working on top of Spark that enables processing of data streams. And these data streams, in order to use it, we use this stream. It's just a sequence of RDDs. So there are many kind of streaming platforms or software in order to process data, streaming data. For example, Kafka, Flume, Kinesis, whatever. So, but here, Spark based or use some operation based on Kafka, Flume, Kinesis. So you can connect or interact your Spark streaming with Kafka, Flume, Kinesis, and HFS over sources outside of Spark. They support some languages as Scala, Java, and Python. So, for example, here we have microbatch. Okay, we have, for example, imagine you have a waiver and you want to do some agriculture. You have many information, for example, about your which kind of phenotype, which kind of the color, maybe of your leaves. I don't know what you want. So all of this, you have all information. We try to have. After that, we have a batch. So batch of information, and we try to process it with SparkSession. So it will take your batch and split it in one stream and batches based on some seconds. And after this, each batch is treated as an RDD, and the result, sorry. Okay. So the results of RDD operation are written as batch. Okay. So about Spark, what I can say, it enables to develop some machine learning application. For example, if you want to use classification, regression, collaborative filtering, clustering, now it's possible to use deep learning. There are two packages. So first one is MLlib. It's just on top of RDDs, and the last one is ML, is just on top of Dataframes. So it's part if you want to use this API, so you want to use this part of Spark, but in order to process your to make some prediction, they support some languages like Scala, Java, Python, and R. So ML, as I said, is based on Dataframes. So they can use some elements like transformer, estimator, evaluator. So what I can say, when we talk about Spark, today several industries use Spark in order to pre-process or to process their data. So it says that is 10 to 100 faster than Hadoop. in order to make it enables to make data analytics fast, because there are several APIs and are all of its rich. Spark is a framework for large-scale parallel processing, and you can integrate Spark with many components. So it's what I can say about Spark. Thank you. Thank you for your attention, and now you can ask your question. Thank you.